Hello, thank you for tuning into this video focusing on nested structures for data analytics in Pandas. One of the emerging challenges in data analytics, in addition to the sheer volume of data and the velocity at which data analysts will receive them, is also the challenge of a variety of data. Simply that data can really come in various shapes, forms, and types, both in structured and unstructured data file formats. But under the structured data file formats, data really can be expressed and serialized in many ways. But the more popular main three categories of data can really be categorized as text delimited files, nested files, and binary files. Text delimited files are the typical format that a lot of analysts are well known and well received for importing and exporting operations. And these include the very popular comment separated values, CSV, tab delimited, pipe delimited. And these are essentially text files that are rectangular in shape, with rows and columns format in a two-dimensional structure, and with column headers sometimes are, but usually intact on the first row. And these nicely and can seamlessly map into data frames such as pandas, rows, and columns. However, the nested file types are a different type of data expression, where data doesn't is not situated in a rectangular format, but more in nested format. And for this reason, data analysts must use specialized tools to parse and extract various information and map them into the row and column structure of data frames and data sets. And then comes the binary files. These are more machine readable formats. That really are extensions of software, such as Excel spreadsheets, Stata data sets, SAS data sets, MATLAB files, and even Python has its own binary format known as pickles, which can certainly store pandas data frames and NumPy arrays even. And so this video is going to really focus on the second type of the nested textual based data formats, and really to help that data analysts, with a short primer introduction what these types of files are, the main one, XML and JSON, and really how to work with them in the data analytics environment. So the first one, XML data. XML stands for Extensible Markup Language. This is essentially a set of rules for encoded documents. It follows a tree-like structure, and I'll show an example of this where the data starts at a root, and then file, and then descendants tree expand outward underneath as descendants of the root. This has been and it's designed to be both a machine readable and human readable format. It's been a decades long standards and specifications, really since the dawn of the computing age, and really has been formalized under W3C standards since the advent of the internet in the early to late 1990s. And because of its rule specifications, it's really been adopted by a lot of domains in their formalized procedures and protocols, such as spatial data, the key whole markup language, KML, very popular format in that scope, math ML, music XML in those domains, RDF for documentation, RSS for news syndication, SFG for graphics protocols. And so data analysts likely at some point in their work and journey will interact with XML files. They're still used and continue to be used in APIs, archives, data dumps, metadata, especially with use of portals and repositories. You'll see XML data really a consistent format used throughout. So data analysts should really not be intimidated by them, but really become very familiar with its context and how to interact with them. And to illustrate the nested tree structures, XML and JSON, I'll be using data from the city of Chicago, CTAL rides, available from the city of Chicago data portal. In addition to its export features, also in CSV, it also has an XML output, which I indeed used in this example, a smaller version for illustration purposes. One great aspect of XML, being an industry language, it's respected among a lot of programming languages, including Python. Part of the standard library of Python holds the XML tree elementary module, which can really do many of the basic parsing and operational needs on database on XML. A third-party package provides a more powerful and more robust handling of pretty much anything related to the XML document, specification. It supports Xpath and XSLT 1.0, and so really it's just a added robust layer for any sophisticated operations. So the first step you'll need to do with any XML file or even string format is to import into your environment. And so essentially through the parsing process. And so this is really the Chicago CTA XML format. As mentioned, XML starts off with a single rule, and then from there out branches out to its descendant nodes. And so every element opens and closes within their space. And so as you can see, response closes at the end. The one thing to know, XML does not have a standard format, unlike CSV or tab delimited, pipe delimited files that always are in the row column delimited by those special characters. XML does not have a standard format. It's really an open-ended design type left to the designer. And so in this particular format, this is a very shallow one level nested XML document, and this is the most conducive to migrate into the row column two-dimensional structure of data frames. And so we can seamlessly, without much work, parse this into it. So this is the format ideally you want to receive it or redesign into this format, for your import needs. XML, in addition to how the elements open and close, one thing to know is data can either reside in attributes. These are key value pairs assigned with the equal sign that are situated within a single element. And elements themselves are angle bracket, open and close items that retain text values. So as you can see, rows and all its elements are repeated in the serialization, but the text values differ. And so as you can imagine, we're going to migrate each row element as a row in the data frame, and then its children will become columns. So station ID, station name, month, these will become columns, and the element values will be values under those columns per row. So with that in mind, we can go ahead and start our operations on it. One thing to know, Pandas has yet to implement a read XML handler. It has a read HTML, read CSV, read JSON, but does not have a read XML. And this is probably coming in the works. So until then, we will have to use an alternative route. And one route to go to use is the merge dictionaries via a nested list dictionary comprehension. Essentially, you parse, you locate the set of the nodes you need, and then iterate really across its children. And so here we're parsing to the row level. As you can see, there was a child of the root, but then the grandchild of the root is the sets we want to import. And then once we're on that outer level loop, we then loop within for all of their corresponding children. And then to retrieve the attributes, we can use this attrib dictionary, which is a nice handler for all the attributes within the element. and then we pass it into the data frame constructor. One great aspect of this Pandas data frame constructor is that it can receive many data structures and migrate it, upsize it into a data frame. And this includes lists of dictionaries, dictionaries of lists, tuples, sets, numpy arrays, panda series, and all combinations of those to really migrate into a nice data frame overall. And we do just that. We use the power of that constructor to build out. So all of our element values become their own column and rows, and then the attributes are the last columns. One great aspect of working with XML is that it comes with a few sets of great tools to help the analysts really parse the data, and XPath is one of them. XPath is a query language to search and retrieve nodes within XML documents. And we were actually using a very limited version of XPath, just on the named elements, but we can extend it outward and run conditional logic. We can select various nodes with names. We can do very sophisticated searches across that, and to do that, we'll have to use an LXML package, that third party package that supports the XPath call. So we're doing the same row to row, but this time we're gonna query it to only retrieve data from the Midway Airport, the beginning of the Orange Line in Chicago, and then retrieve all of those rows that had average weekday rides less than 3,000, and we get an output just in that specific condition, and then obviously data goes back to 2001, but interestingly, only the atypical year 2020 fulfills that condition. So again, the same setup of using a list dictionary comprehension and mapping it to a data frame constructor call. And again, one thing to note too about XPath is sometimes the data analyst doesn't need the entire XML document. Only a few rows or nodes or special specific attributes or values within the XML document. So this is a great tool to really just hone in and extract only the needed data. Because recall, the XML wasn't designed for the data analyst, or it was for other reasons, namely the web application or the software tool. But we data analyst comes ad hoc after the fact and are just using the data as is, and so only just needs a small part without all the meta or all the extraneous information. So XPath can really allow the analyst to just extract the needed information for their purposes. As mentioned earlier, XML does not have a standard format. It can get really nested and dense. And this is just an example of just that nested quality. We still have our rows that we want to migrate. However, now we have two levels that we have to incorporate. One level here is now the attributes of the stations, station ID and name, are now encapsulated inside the station element. And then all the rides details are now under the rides element. So in order to retrieve that station data and then the rides, we have to go one level deeper, and this can even get even more dense. So this is just one example of how to handle this particular use case. We can still work with our merge dictionaries and the Pandas data frame constructor, but this time we'll have to expand it outward. We'll be now merging three sets together, the station attributes with their corresponding key value names, and then month, migrate that, and then all of the children of rides. We don't want to bring in rides, we want to go down to the rides level, so we'll use that forward asterisk XPath call, and then return the data as needed for a list of dictionaries that we pass into the data frame constructor to get our data situated in the row by column two-dimensional structure. So just know that the data analyst, again, you have to review the XML carefully, understand its shape and scope, and then just start parsing accordingly. So that extra step is needed for that route. And sometimes the XML can be very dense, very nested, that it really becomes a challenge to really work with. That we'll need yet another tool, and this is another great tool. XSLT is a scripting language designed to transform XML documents, and not only just XML to XML. It could be XML to HTML, XML to even CSV, text files. And it's a declarative programming language, a recursive, functional style that it may be a little tough to work with folks in the object oriented paradigm, but nonetheless, it's a very powerful tool to really shape the XML documents into the end use need we need. And particularly, we're going to work with that nested XML. We're going to flatten it out for our migration needs. And for this, XML XSLT is written exactly in an XML format. It's a fully compliant XML document. Only has special tags that really are used as commands, declarative commands sent to the XSLT processor. What we're really doing is redesigning only one particular element. We first start with the root, and we tell the processor, all right, start from the root, and then now apply our new specifications to the role. What are those new specifications? It's in the second template that we copy. It's root, being the corresponding row node, and then mapping the ID attribute, the station attributes, and creating new elements that correspond to those attributes, station ID, station name, and then we're going to copy over its sibling month, and then all of the children of rides. Again, we want to remove the rides nest element and and extract out the children with that forward asterisk call. So XSLT is a sibling of Xpath, and so it can also run Xpath within its document. And so that's the great aspect of that. And again, we need to use the LXML package for this. We can import it as a string or from a file disk, parse it, configure our transformer, and then pass in our original document to create a flat document or a transform document, which here being the flat version of that. And then we can go ahead and run this with the aforementioned approaches to migrate that into a Pandas data frame. So while XML can be a very formidable data type, it really has great tools to help the analyst migrate the needed data for the end use needs. And it comes in the yet another popular nested data type, and this is the JSON data format. JSON standing for JavaScript Object Notation. Instead of the tree-like structure of XML, this runs more on a map and key value structure. And using brackets and curly braces to situate the data. It's an emerging web application data format, especially in the more interactive Web 2.0 age, where a lot of data is being moved back and forth from the back end system into the user interface. And so there's a lot of rendering on the web page that JSON just helps, and is a very conducive format for that. It's less restricted without the markup rules of XML. The same data is stored in a smaller size footprint because it avoids all the redundancy and verbiage of XML. And so a lot of programmers will use this for a lot of serialization and transfer back and forth. Much like XML, Python has a built-in module for JSON that ships with this standard library. So no third-party extension is required. And so just to show you how a JSON looks, we read it from its text file format and output it to the console. And as you can see here, in JSON, the square bracket denotes a collection of data, and then the curly braces is where that key value mapping is situated. Keys corresponding with their values, and then and even within these, it can have its own key value pairing, and so this can really get very dense. This is a very flat version of the CTAX Chicago monthly LRISE data. And as you can see here, each one of these sets is going to migrate as a row, where the keys become the columns and the values become the cells under those columns for those corresponding rows. So one great aspect of Pandas, it has a nice support for JSON types. So it does have a read JSON handler, where you can read directly from the JSON file into the Pandas environment. And once and on a very flat version, no other step is needed. It migrates seamlessly into the row column structure, two-dimensional structure as needed. But like XML, JSON can get very dense and very nested. This is an example of such a nested structure, almost analogous to our XML example, where we now have a station element, and then we have a rides element with their child key value pairing. And then we'll still need to migrate the row level sets. However, we have to go one step deeper in order to retrieve those underlying values. And again, if we were to just quickly run read JSON, it won't work, because those nested formats will migrate and are stored within the cells of the data frame, and so this won't be conducive for our analytical needs. As each of those nested columns will have a dictionary object rather than scalar values accordingly, and so we need another workaround approach. Again, back to Pandas being a very great handlers for JSON types. It has a JSON normalize method, where it'll normalize data or flatten it out into the structure needed. And one great aspect of JSON normalize is, by default, it goes one level deep to extract the needed data. And if it's all aligned on the same length, it can seamlessly work. And so once we load, we'll have to load the JSON in through the Python side using the JSON package, and then pass in this list of dictionaries or dictionaries of lists, however this comes out, pass it into the JSON normalized call, and get our nice tidy data set overall. And you'll see that it, by default, is prefixed with their corresponding parent element name. So station and rides are period qualified columns when we use this method. However, if we didn't know about JSON normalize, we can still use our earlier approach of merging dictionaries via list comprehension, and then pass that into the data frame constructor. So we'll load our nested JSON in the Python variable, and this just shows a print output of their types. It's a list of dictionaries, and again, that's a nice format for a data frame constructor. However, our underlying dictionary is very nested, and so we'll have to do a little wrangling to flatten that out. And within our list comprehension, we're going to use the merge dictionaries method with the double asterisk, and then to flatten all those underlying dictionaries into one dictionary per row, per list item. So extract the JSON set, the month set, a month with just one member dictionary, and then the ride set, all their children, and migrate that accordingly to a nice data frame overall. So I know this was somewhat long-winded, somewhat extensive in various use cases, but I hope I was able to give a nice introduction and show the data analysts how to work with these very special types of data formats. Unlike the text format of the rectangular that seamlessly just migrates into the row column two-dimensional structure of data frames, XML and JSON really requires the analyst to go a few steps early within, to extract the needed data and migrate that, into the row column sets available. Some methods are available. Some requires workarounds, but do not be intimidated. Take each step at a time. Review the XML and JSON before extraction, and you should really be able to have a nice and handler overall. So I hope this was very helpful to you, and thank you for your time and attention.